Hello my test tubes and welcome to another STEP preparation video. Today I'm going to be going over 2019 Step 1 Question 5. So for the first part, we have two vectors, PQ and SR, and they are indeed equal and parallel. And we have two parallel lines basically, here's PQ, SR, and so the lines connecting them are just going to be shifts of one another, and so they're going to be parallel as well, so we have a parallelogram. The part of the question is short, so like if it's the first part of the question and it's relatively short, then it's probably going to be that you either explain something really briefly or you don't explain it at all. So I think my explanation right now is suitable. Then for part for the second question of part 1, PQ is equal and parallel to SR, and also PS is equal in magnitude to PQ. And so we have this strange shape such that the lines are all parallel and the magnitudes of all vectors are the same, and so that's rhombus. So here I've drawn for simplicity already the points P, Q and S, and the plane is uniquely determined by 3 points. So if I draw a plane through the 3 points P, Q and S, then that plane is going to be uniquely determined no matter the value of R, and then if we want R, which lies over here because it's R11, lies on this plane, then it's going to have to be the point which intersects with the plane passing through P, Q and S. So, drawing the plane that passes through P, Q and S, we have, sorry for the rubbish drawing, something like this, and so R is going to be here, and this plane over here passes through two parallel planes, the two parallel planes here, front plane and the back plane, and so these two lines are going to be parallel because the plane passes them in exactly the same orientation, and here the ratio is going to be R1 minus R, and so these two triangles, this one triangle here and this triangle here, are going to be similar, because the planes are parallel and these sides are parallel and these sides are parallel also. And so that means that the ratio of the vertical side here to the ratio of the horizontal side is the same in both triangles. So R over 1 minus S is equal to 1 minus P over Q, and so QR is equal to 1 minus P times 1 minus S as required. Okay, so for the next part, we've already determined that PQ and SR are parallel, and if they are equal, that means that these two triangles that we explored before are going to be equal as well. And so that means that 1 minus S is equal to Q, and 1 minus P is equal to R, and so S plus Q equals 1, and P plus R equals 1. That's if and only if SR is equal to PQ. And then let's just find the centroid in the general case. That's going to be P plus Q plus R plus S over 4. So P plus 1 plus R plus 0 plus Q plus 1 plus S, and 0 plus 0 plus 1 plus 1, all a quarter of this. And here we see that if and only if S plus Q equals 1 and P plus R equals 1, this is equal to a half times P plus R, 1 plus 1, 2, Q plus S plus 1, 2, and 2. So that's if and only if this. And this is if and only if this. And this is equal to a half, a half times 1, 1, 1, which is exactly the center of the cube. So the centroid is exactly at the center of the cube if and only if S plus Q equals 1 and P plus R equals 1, which is if and only if SQ is equal to PQ. as required. If then we have PQ equals SR and PQ equals PS, then express QR and S in terms of P. Well, PQ equals SR means that, this looks like a really bad drawing, but the corner here doesn't pass through the line PS. Then we have PQ is equal to SP, so calculating PQ, that's just 1 minus PQ squared actually, squared plus Q squared, is equal to this value, which is P squared plus S squared plus 1 squared, giving me 1 plus, minus 2P plus Q squared plus P squared is equal to P squared plus S squared plus 1. Cancelling the 1s and the P squared, we get 2P is equal to Q squared minus S squared, which is equal to Q minus S times Q plus S. And oh look, how convenient, the Q plus S is 1, and so 2P is equal to Q minus S. And so 2P is equal to Q plus S minus 2S, giving 1 minus 2S, and so P is equal to a half minus S, and similarly also P is equal to, so S is equal to a half minus P, and then Q is equal to a half plus P, just rearranging, and also R is equal to 1 minus P. Got these three. When we're asked to show the value of cosine PQR, I'm just going to say that cos PQR is equal to QR dotted with QP over the absolute values of QR and QP. Equal to, let's find QR first. That's going to be 1 minus R in the X, R minus 1 in the X direction. In the Y direction is going to be 1 minus Q, and in the Z it's going to be 1. And then QP is going to be 1 minus P in the X direction, Q in the Y direction, and 0 in the Z direction, then divided by QR times QP. I'm not going to expand these just yet because all of these are in terms of Q, R, and P, and I want to convert everything in terms of just P, because I think that's what we've been asked to do in the first part, so it's probably going to be useful if we do it now. This would give me minus P a half minus P1 dotted with P minus 1 minus P minus a half and 0. And divided then, now I can use the correct values of these. So QR is going to be P root P squared plus half minus P all squared plus 1, and the absolute value of QP is going to be P minus 1 squared plus P plus a half all squared. I decided not to put the minus sign for obvious reasons, plus 0 squared, so just that. Then expanding the top part, that's going to be P minus P squared plus P squared minus a quarter over, this is root expanding all of these roots, that's going to be 5 quarters minus P plus 2P squared times the root of 5 quarters minus P plus 2P squared. Okay, so the P squares cancel out here, and we have P minus a quarter over 5 quarters minus P plus 2P squared. And that already looks very similar to the formula that we have here. And just to check, I think all we have to do is multiply everything by 4, so top and bottom by 4. That gives us 4P minus 1, so numerator correct, and denominator 5 minus 4P plus 8p squared is also correct. Next, for the values of p, q, r, and s, if p, q, r, s is a square, well, if p, q, r, s is a square, then p, q is perpendicular to q, r, so the cosine of p, q, r is going to be 0, so 4p minus 1 is equal to 0, so p is equal to a quarter, and plugging this in we get s is equal to a quarter also, and then q equals r equals 3 quarters. And write down the values of PQ, write down the length of the side of the cube. Well, the length of the side of the cube is just going to be either like absolute value of QR or QP, or any of the other side lengths. But we already have QR and QP in terms of P, so that's going to be root 5 quarters minus P plus QP squared, which is root 5 quarters minus 1 quarter plus 2 16ths, which is equal to 18 16ths, which is 3 root 2 over 4. So we've got that the length of the side is 3 root 2 over 4 exactly, and we want to show that this is larger than 21 over 20, and to do so, let's multiply both sides over here by 4 divided by 3. We get root 2 larger than 7 over 5. So if this is true, then this will be true as well. And multiplying by 5, this statement is equivalent to 5 root 2 is larger than 7. And because both of these are positive, if we square both of them, we get 50 is larger than 49, which is definitely true, which means that this is true because that's just the square root of both, the positive square root of both values. So this is true because this is just multiplication by 5 both sides, and then this is definitely true as well because that's just division by 4 multiplication by 3. So we have it. Thank you guys for watching, and I hope that your exams go perfectly well.